Okay, let's review a little bit about symmetry. A figure is going to have symmetry if there's a fold that maps the figure onto itself. So a figure in a plane has line symmetry if the figure can be mapped onto itself by a fold in the line. If you fold the figure on a line of symmetry, the two halves match exactly. The folding line is your line of symmetry. And in this figure, triangle ABC has symmetry because ABD, triangle ABD, is congruent to triangle CBD. BD is once again called the line of symmetry. So if you take half of the big triangle, this is your line of symmetry, and on the other side would be exactly the same half. Okay, so each figure is going to show a shape folded along the line of symmetry. So the dotted line is going to be your line of symmetry. So just pause the video, take a few minutes, and try your best. I know it's a little bit difficult to make it exactly the same, but draw a picture showing how the figure looks unfolded. So what does the other half of this look like? Okay, so you should have something that looks a little bit like this. So in the rectangle to the left, these are all the figures that have line symmetry. And remember, if you're not entirely sure if it has line symmetry, just to trace the figure on a piece of paper and then fold it and see if the two halves fall on top of each other equally. And then here's an example of a few figures that do not have line symmetry. Now we're going to talk about rotational symmetry, and it's exactly like it sounds. You're going to rotate an image, and if the image can be rotated and it falls back on itself, then it has rotational symmetry. So rotational symmetry is if there's a rotation between 0 degrees and 360 degrees that maps the figure back onto itself. The order, when I ask for the order, it just means how many times can you turn it before returning the original figure, and then how many times can you turn it to get it back on itself before returning to the original figure. The magnitude is the angle of which you turn each rotation. So how you figure out the magnitude, you're going to have to break each figure up into a circle and figure out how many degrees each angle you turn it would be equal to. Okay, so what I've done using this figure right here is I've traced it, and what you should do is trace this figure on your patty paper. Just a rough outline, just like you see here. It doesn't have to be perfect, but it's just so you can get a visual. And we're going to see how many times we can turn it where it'll fall on itself and then all the way back to the beginning. So as I'm turning it, move it over a little bit. That's one turn where it fell back on itself, but we haven't gone all the way around yet. Here's two turns where it fell. It's the second turn where it fell back on itself, and we're not at the beginning yet. And here we are back at the beginning. It took us 3 turns to get back to the beginning, and with each turn it fell back on itself. That is called the order, is how many times the image is turned to get back to the original. The magnitude is you just take the idea behind a circle, the fact that it's 360 degrees total that you can turn the image, and divide that by the order, the number of times you turned it. So 360 divided by 3 gives you the magnitude, and it basically means that each turn you made was 120 degrees. Okay, So we're going to do that again. I would like for you to trace this, and as you can see, my tracing isn't perfect. It's just a rough tracing so that you can get an idea of what it looks like after you turn it. So just do a little rough sketch of the figure in the second example on your patty paper, and go ahead and turn with me. As you can see, we turn it once and it falls back on itself. Twice, falls back on itself. 3 times, we're not back at the beginning yet, and 4 times. So we turned this a total of 4, that's our order, and the circle has 360 degrees, or we turned it a total of 360 degrees, and that 360 was split up 4 times, and that's going to give us a magnitude of 90. Okay, so I'd like for you to pause the video and see if you get 12 as your order and the magnitude of 30 when you trace and turn this figure. And just a little hint when you're tracing. This one you can kind of just do like on your patty paper, just do like little circles. And mark your original position on your patty paper so that when you turn, so just like I had here, when you turn it, you know where your original is. Okay, so 1 through 6, determine whether the figures below have rotational symmetry. If they do, please determine the order and the magnitude. Okay, so just take a few minutes to try 1 through 6, and I'll have the answers up in just a moment. Okay, and these are the answers you should have gotten. If you didn't, raise your hand if you had a hard time seeing them. Hopefully you're at the point where you can kind of see them without having to trace them on the tracing paper. You kind of just basically break it up into sections that are the same. So if you have 8 of the same sections, that's your order, and 360 divided by 8 gives you your magnitude. Here you have 6 sections that are all the same, so your order would be 6 and your magnitude would be 60. Okay, and then just to recap, the rotation is a transformation which turns a figure about a fixed point. The order is the number of turns. If we have to turn a point, so let's say that we want to rotate a point E, and we want to figure out how would we get E to X. Well, this right here would form your angle of rotation. And to figure out what the angle of rotation is, it's going to be the same as your magnitude. So we take the order, that's going to be 1, 2, 3, 4, 5, 6. We take the order and divide it by 360. So we get each of these has an angle of 60 degrees. Okay, so let's do a few examples using this as our point of rotation. To name the image of E, so here's E, after a 60 degree rotation about N. So we're going to actually go clockwise. It doesn't specify, but it should specify. So we're going to go 60 degrees. So if each of these angles is 60 degrees, then E, if we turn it 60 degrees, would fall onto point X. If we start with X as our point, and we go 180 degrees, so we have to figure out how many 60s it's going to take to get to 180 degrees. So we have 180 degrees, so we have to divide that evenly amongst 60 degrees. So we're going to have a total turn of 3. So that means we have to take X and turn it 1, that's 60 degrees, 2, that's 60 degrees, 3, that's another 60 degrees, and that's a total of 180 degrees. So our point that I've covered up is point O. Okay, so now I'd like for you to finish the last 4 and pause the video and see if you get what I get. If you did not get these answers and you're not sure how to do it, raise your hand or ask a neighbor. So all of those rotations were done not on a coordinate plane. Now we're going to talk about rotations that are done on a coordinate plane. You're going to have to know and memorize 3 rules. You have the 90 degree rotation, and usually we're talking about counterclockwise, so always go counterclockwise. Go with the quadrants, 1, 2, 3, 4, unless it specifies otherwise in the directions. So if you're taking a point in the coordinate plane and you rotate it 90 degrees counterclockwise, one thing you can do is trace it on a piece of tracing paper, but make sure you trace the coordinate plane with it so that you can align your origin back to its original. That would be great, you could do that, but you're not going to always be able to do that like on the SOL. So the rule that you'd have to memorize is if a point is rotated 90 degrees counterclockwise, that the x and y value changes to negative y, positive x. So this is my original 5, 2. So my x is 5, my y is 2. So my new coordinate is going to be negative y, so I take 2 and make it negative, and I take x and I just put it in the y's position. So this point, rotated 90 degrees, comes out to negative 2, 5. If you rotate the point 180 degrees, so now we're down here. The rule for that is the x and y coordinate. So here we have 5, 2 again. X is 5, y is 2. The x and y coordinate become negative x, so it just becomes a negative 5, and negative y, negative 2. And then finally, a 270 degree rotation, you take your x and y values, so x is 5, y is 2, and you switch the y position, so 2 is first, and you make the x a negative, or the opposite. So if it's already a negative, it becomes a positive. Okay, so if we have a parallelogram with these vertices, graph its image after a rotation of 180 degrees. So all we have to do is look at our chart, and the rule for 180 degrees is you take your xy coordinates and you make the x negative and you make the y negative, or the opposite sign of what it already is. So 2, 1 is our original. That's going to become, after rotation, become negative 2, negative 1. G is 7, 1. So G prime is going to be negative 7, negative 1. H is 6, negative 3. So here's where you just change the sign. You're making it the opposite sign. So H prime becomes negative 6 and a positive 3. And then finally we have J, which is 1 and negative 3. So J prime is going to be negative 1 and a positive 3. Okay, so just pause the video, take a second, and plot those points. Make sure it looks like mine after you're done. Okay, so when you graphed FGH, J, this is the pre-image, and then F prime, J prime, H prime, and G prime. This is the rotation of 180 degrees. Okay, so look at your rule chart above and tell me the answer of the triangle being rotated counterclockwise, so just like we learned about the origin. What would point J be if we rotated it counterclockwise about the origin? So look at your chart, pause the video, and see if you get what I get. So the rule for a 270 degree rotation is your xy becomes y negative x. So x was 3, y was negative 7. It would become y, which is negative 7 first, and then 3, but we want it to be negative, so negative 3. So your answer was C. Alright, for the next example, I'd like for you to plot the points S, T, and U, and then under a 90 degree rotation, plot and tell me the coordinates of the points S prime, T prime, U prime. So pause the video and see if you get what I get. So STU is my pre-image, and then after a 90 degree rotation, it's S prime, T prime, U prime, which is halfway in the, well, not halfway, but it's mostly in the second quadrant, and some of it is in the first quadrant.